All right, let's just jump right in with a question that's probably crossed your mind late at night. A question that kind of blurs the line between science fiction and, well, actual science. What if none of this is real?
So, I'm asking you right now, look around. That screen, the room you're in, your own hands, is it all real? Or could it just be part of an unbelievably advanced computer program? It sounds crazy, but some very smart people argue it's not just possible, it's actually probable.
And look, this isn't just a fringe idea cooked up on the internet. When someone like Elon Musk says the odds are billions to one that we are not in the original base reality, you kind of have to sit up and pay attention. It really sets the stage for what we're about to dig into. So, where did this whole idea even come from? Let's break down the actual argument for simulation theory, and it starts with an Oxford philosopher who really pushed this into the mainstream. Okay, so the official name is simulation theory. The core idea is that our entire universe is just a super sophisticated artificial simulation. And the guy who really laid it all out was Nick Bostrom, back in a landmark paper he published in 2003.
Now, what's so brilliant about Bostrom's argument is how he framed it. He called it a trilemma and said, look, one of these three things has to be true. One, any civilization smart enough to create a simulation, well, they just wipe themselves out first. Two, they get all the technology they need, but for some reason, maybe ethical, maybe they just get bored, they decide not to create any. Or three, we are almost certainly living inside one right now.
And the logic behind that third option is kind of hard to argue with. Think about it. If a civilization can create just one of these ancestor simulations, they're not going to stop there, right? They're going to create thousands, maybe billions of them. And then, what if the people inside those simulations create their own simulations? It's like Russian nesting dolls of reality. So what are the odds you're in the one single original doll versus one of the billions of copies? Yeah, statistics are not on your side. Okay, so if we're living inside a giant computer program, shouldn't we expect to see some bugs? Some glitches in the matrix? Let's start looking for clues. And we're going to start small, with the weird stuff that happens in our own heads. You've probably heard of this one, the Mandela effect. It's this bizarre phenomenon where millions of us have the exact same false memory. For instance, I would have sworn the Berenstain Bears was spelled with an E, and the Monopoly Man totally had a Monaco, right? Nope, never did. That iconic Darth Vader line, it's actually, "No, I am your father." And that cornucopia in the Fruit of the Loom logo, it was never there. Is it just our memories playing tricks on us, or could these be tiny edits, patches to our reality's code? And then there's that other glitch we've all felt, deja vu, that uncanny feeling that you've lived this exact moment before. Well, the legendary sci-fi author Philip K. Dick thought it was a clue, a sign that a variable in the program had just been changed, and we were briefly sensing the system reloading. Okay, so let's zoom out. Way, way out. Let's move on from our own minds and start looking for clues written into the very fabric of the cosmos. Because if our universe is a program, then the laws of physics, that's the source code. And let's just start with the scale of this thing. Just look at that number. 200 billion trillion. That's our best guess for how many stars are in the observable universe. It's a number so big our brains can't even really process it. And that's a whole lot of places for life to pop up. Which leads us to a huge and kind of spooky question known as the Fermi paradox. With all that cosmic real estate, why is it so quiet out there? We see no evidence of any other advanced civilizations. The silence is deafening. But a simulation theorist has a simple answer. Maybe they just haven't been rendered yet. Maybe our little section of the simulation is what's in focus, and the rest is just a very convincing backdrop. And beyond that, the universe itself seems to run on rules. It feels programmed. I mean, the speed of light is a hard-coded speed limit. Nothing can go faster. Some physicists, like James Gates, have claimed they've found what looks like literal error-correcting computer code buried in the math of string theory. And then there are these beautiful mathematical patterns like the Fibonacci sequence that show up everywhere, from the petals on a flower to the spiral of a galaxy, even in our own DNA. Is that all coincidence? Or are we seeing snippets of some really elegant code? And all that brings us to what might be the weirdest, most compelling, and honestly, the most reality-bending piece of evidence we've got. This is the potential smoking gun, and it comes from the truly bizarre world of quantum physics.
It's called the double slit experiment. Now, the setup is actually pretty simple. You're just firing tiny particles, like electrons, at a screen that has two little slits in it. And all you're trying to figure out is, do these little things act like tiny, solid balls, or do they act more like weight?
Okay, this is where your brain might start to hurt a little. First, let's see what happens when we shoot these electrons one at a time, but we don't put any detector there to see which slip they go through. We're not watching. The result is, well, it's impossible. They don't land in two neat lines like you'd expect. Instead, they create a wave pattern on the back wall. This pattern could only happen if each electron went through both slits at the same time and then interfered with itself. For a single particle, that makes absolutely zero sense. So naturally, scientists were like, no way, we have to see what's happening. So they tweaked the experiment. They just put a tiny little detector right by the slits to see which one each electron actually goes through. So what happens when we're looking? The second we observe them, everything changes. The wave pattern completely vanishes. The electrons suddenly start behaving like normal little particles again, making two perfect lines. This simple act of looking at them forces them to choose. It's as if reality doesn't bother filling in the details until a conscious observer looks at it. Exactly how a video game engine works, only rendering what's on your screen to save processing power. Now, obviously, not everyone is buying this, so let's give the skeptics their due and look at the biggest counterargument. Could you even build a computer powerful enough to simulate an entire universe? So you have brilliant physicists like Michio Kaku, who say, look, it's a non-starter. There are just too many atoms in the universe, it's computationally impossible. But the comeback to that is so clever. You don't have to simulate every single atom all the time. Just like in a video game, the system only has to render the bits of reality that are actively being observed. Everything else is just potential, unrendered code, waiting for you to look at it. So we've looked at the glitches, the code, the paradoxes, but the deeper you go down this rabbit hole, the more it leads you away from physics and brings you right back to philosophy, to a really, really old question that's just wearing some new digital clothes. Because a really interesting thing about this theory is that it might be impossible to disprove. I mean, how can you prove you're not in a simulation? And if you think about it in this framework, the Big Bang was just the moment the program was turned on. The creator of the simulation would have to be an all-knowing, all-powerful intelligence that exists outside of our space and time. And that starts to sound an awful lot like God, doesn't it? And that's really the final mind-bending takeaway. When you strip it all down, the simulation theory is just a modern, tech-savvy version of one of humanity's oldest beliefs, that our world was created by some higher intelligence for some purpose. So the final question I'll leave you with is this. Whether you call that intelligence a programmer or you call it God, at the end of the day, what's really the difference?